All right, so a little single replacement predicting. We've got rubidium plus water, liquid water there, and manganese plus water, again, liquid water. Try and predict these without my help first, and then kind of, if you can't do that or whatever, go through as far as you can and watching and try and pause me as I'm going and work ahead. So I look at my reactivity series list, right? So I find rubidium on here. I recognize that it's single replacement because I've got an element and then a compound. And when it's water or an acid, you kind of want the words more than the elements there, right? So I see rubidium is right here towards the top, very reactive element. And it says very reactive, will even react with cold water to make metal hydroxide. So a metal hydroxide, right? Hydroxide's OH. So I'm going to make rubidium hydroxide. So it's going to be RB. And then hydroxide is OH. Now I need to think charges as I put those together. So rubidium is right here in column 1. So that gets a +1. Hydroxide on the back of our periodic charts is OH. Where's hydroxide? Right there. Hydroxide's OH with a -1. So that's a +1, -1. So just one of each of those works just fine. But that only kicked out one of the hydrogens. So the hydrogen's over here, but hydrogen is one of those Hunkelbriefs. So it can't exist just as hydrogen. It's got to exist as H2. I can, right? So whenever hydrogen's by itself, it's H2, and then we would make rubidium hydroxide. I'm not as worried about states because single replacement reactions aren't driven by states. They're driven by reactivities. So we could look and see, it is dissolved, it's soluble, so it'd be dissolved in water. You put an AQ, that's a gas and stuff, but that's not really the driving force there. Now that is showing 3 hydrogens and there's only 2 here. So we could deal with that though, right? We could balance this thing if we wanted. Right? Again, I didn't ask you to in this question, but we can deal with how many hydrogens there are just by saying, well, now there's 4 hydrogens on both sides, 2 oxygens on both sides, 2 rubidiums on, right? So 2, 2, 2, 1, right? We can deal with that. That's not a problem. So then we look at the next one, manganese plus liquid water. If you didn't do the first one on your own, maybe try and do the second one on your own. Find manganese, Mn. So it says reactive. Will react with steam to make a metal hydroxide. Well, this says liquid water. There's no, maybe if they put a triangle above this to show that we heated it a bunch or something, but it says it'll react with hot water, not react with cold water. Certainly not in any reasonable speed, maybe over a month, right? But when we're doing this, we're talking about reasonable. So we'd say no reaction here. Right? So that's kind of boring. So let's say instead it said gaseous water. Well, now that water's got more energy. So that's going to happen now, right? On a test, if I gave you this and it said liquid, we'd say no reaction. But if it said gas, a reaction would happen because now you've got steam, you've got hot water kind of thing, right? And you could ask for clarification on it. You could say, well, it says gaseous water. Does that mean that it's hot? Oh, yeah, right? That's how we make water into a gas, is we get it hot. So as we do this, I would have to tell you on the test, hey, if this reacts, manganese gonna get right? Because manganese can get several charges. So a common charge for manganese is +7. So let's say it gets a +7. Well, if it gets a +7, manganese is +7, hydroxide's -1, so it'll be MnOH7. Actually pretty uncommon for it to get a +7, but we're just gonna do it as a +7. Right, so it gets a +7. That only replaced one of the hydrogens here, so the other hydrogen's by itself. But whenever hydrogen's by itself, it is H2. Right? And I believe that takes care of that one. Right? Let's look at a different style of single replacement. So we've got iron sulfate and zinc. Right? So iron sulfate and zinc. So who are you going to compare? Who's the better, right? This isn't the words on the side. This isn't about what it's going to do with water and acids. This is about 2 of the elements. Who's the better dancer? Who's the better dancer, zinc or iron? Right? So I compare zinc and iron. They're pretty close. They're both right here, right? But zinc is higher up. So zinc is the better dancer and zinc is by himself. So if zinc is the better dancer, zinc is going to knock iron out. So iron's going to be by himself now and zinc's going to be in the compound. Remember, don't bring over the subscripts, except for the ones that are part of the polyatomics. So ZnSO4, zinc sulfate is now our compound. We think charges. Zinc gets a +2, sulfate gets a -2, so one of each of those is going to work just fine. right? And we could balance this thing pretty straightforward just by saying, well, there's 3 sulfates, so a 3 here. That gives me 3 zincs, so a 3 here, and there's 2 irons, so a 2 here, right? Single displacements tend to be pretty easy to balance once you've done a few of those. Most of us are doing just fine at balancing, so not too worried about that. Anyway, hopefully those are helpful. Let's do really well on this test.